Okay, quadratic formula. And the quadratic formula here is derived rather easily and simple if you complete the square on this square. Applies to an equation in this form. If you got anything besides 0 on this side of the equation, it doesn't apply. Okay, so let's solve a couple of equations. Let's see what we get. Right on this thing, it doesn't work. Okay, well, okay, so taking the first equation here, very straightforward. The equation is of this form. So this equation is ax squared plus bx plus c. And we notice that a is a number in front of x squared. And that number is, you can see that. Just temporarily raise the camera a little bit. This camera is absolutely wonderful, except that it won't raise things continuously. It raises things in jumps, and that makes it difficult to keep it focused. Okay, to keep it on the right part of the board. Anyhow, okay, so we have ax squared plus bx plus c equals 0. That's the form of the equation. And again, a is a number in front of x squared. So 3 is a number in front of x squared. So we conclude that a equals 3. B is a number in front of x. You can believe that b equals -9. And C is that number out here without an x on it. So C equals 0. Now here's our formula. We plug in b. We're going to have a b here and here. That's going to be a -9. So we're going to have negative of -9, or negative b, plus or minus the square root of b squared. B squared is, well, b is -9. We have a -9 squared. Now we want to be careful to put parentheses around the entire -9. It's not the negative of 9 squared. It's a quantity -9 squared. So this number is always going to be positive. Then we have -4ac. Well, a is 3. That's going to go here. And c is not 0. Apparently my eyes aren't connected to my brain or something. C is 0 here. I wrote it down. It's 5. Okay, so a is 3 and c is 5. So we have -4 times 3 times 5. That's divided by 2a. So that's going to be 2 times 3. Now we just do the numbers. Okay. Negative of -9 is 9. Square of -9, well, that's -9 times -9. It's going to be positive because you have 2 negatives. It's going to be 81. And 4 times 3 is 12. You multiply that by 5, you get 60. And that's over 6. And well, that gives us 9 over 6 plus or minus. So 81 minus 60 is 21. Over 6. Now, when you divide 6, division by 6 is like a multiplication by 1/6. So that multiplication would distribute. So we have to be sure that we have this over 6 and this over 6. So I'm going to lower the canvas a little bit so we can see everything. And that watermark that goes down here, we got to keep tabs on there. Okay. Well, 9 over 6 reduces to 3 over 2. And the square root of 21, there's no perfect square that goes into 21. The prime factorization of 21 is 3 times 7. Neither of those is a perfect square, so we don't have a perfect square. That's it. And we can say approximately the square root of 21 is roughly 4.7. We can say this is approximately 3/2 plus or minus 4.7 over 6, which is approximately 3/2 is 1.5. 4.7 over 6 is pretty close to 0.8. We're going to call it, oh boy, I don't know how to call this, 0.7. Seven, 8 or 7, 9, we'll say 7, 9. Okay. And that would be then 1.5 plus 0.79 equals 2.29. 1.5 minus 0.79 is 0.79. And a really bad looking line that's 0.79. And that's 0.7, negative 0.71. Okay, those are solutions of our equation. Approximately. Okay. Now, something X equals, right? These are the values of X. And X equals each of these. Now you have 2 solutions. And the reason for 2 solutions comes from, you can understand that by understanding the process of completing the square, which preceded this. But whether you understand that or not, this is how you use the quadratic formula. So your solution set should be written we have plus the square root of 21 over 6. We have minus the square root of 21 over 6. And that's approximately 2.29 negative 0.71. So we're running 9. Okay, now we're going to see what that solution means, but I want everybody, including anybody to come in late, or through Zoom, not late, to Try the same thing for this equation and this equation. We're going to have to go on with this in just a couple of minutes, but give everybody a couple of minutes to see if they can run through a couple of steps. Okay, I said right from the beginning, you got to be careful about signs. What did I do? I wrote down my -4 without a negative. Okay, so and got all the answers right because I did another stupid thing down here, but careless. And you know, in my position, kind of stupid to be careless, isn't it? Okay, so I'll plead guilty. Okay, so anyhow, you do it. You're just being careless until you get experience. But don't be careless because it's going to give you the wrong answer and everything's going to go to. Okay. So we plug in correctly and we get this expression. Then we simply work it out. Okay. And we just go through the steps. Steps are very straightforward. Down to here where we say 112 is the square root of 4, that's 4 times the square root of 7. Do this, we do a prime factorization on 7. On 112. Okay. So that 112 is 2 times 2 times 2 times 2 times 7, which should be written, that square root can be written as the square root of 2 times 2 times the square root of 2 times 2 times the square root of 7. And square root of 2 times 2 is 2, because of course 2 is what you square to get 2 times 2. And same here. And that multiplies out to 4 square root of 7. Something we've done in quite a bit of detail a couple of weeks ago. But anyhow, there it is. And now the simplification becomes pretty obvious. You gotta be careful. You put the 4 over -4 here, the 4 square root of 7 over -4 here. And then, so we don't have to, you could write this as a minus plus this. You're going to get the same thing regardless, but we're going to write it out in detail. We're going to write out -4 over 4 plus 4 square root is negative. I don't like the way that was written out. This should be over -4. Negative shouldn't be in this one. And negative on the 4 here. Okay. So we get, again, 4 plus square root of 4. 4 plus 4 square root of 7 is over -4, quantity over -4. Gives you this. And the minus here gives you this. And now we have a plus. -4 into 4 is -1, so we get a negative square root of 7 there. And similarly over here, -4 into 4 is -1, we have a minus that, so it gives us a plus square root of 7. There's our result. We could approximate that numerically, but I'm not going to do that right now. Okay, let's move on to the third problem. Let's see if I can do this more carefully. I'm going to erase all this stuff about the prime factorization because but that's how we make sure that square root of 112 is as simplified as it can be. Now, there are a couple of things that are going on here. We don't need the quadratic formula to solve this if we realize that this is a quantity x minus 7. Never mind, I don't know what I was just saying. That's 49. What I was about to say. Actually, 49 fourths. Okay, forget what I was about to say. Okay, I'm going to write the quadratic formula again. And note that A is 1, B is -7, C is 14. Now, I'm not going to go through all the details of the substitution. I'm just going to write it down, because apparently if I go through all the details of the substitution, I make mistakes. Okay? So I'm going to make mistakes without doing that. Well, we get x equals negative of negative 7 plus or minus root of negative 7 quantity squared minus 4 times 1 times 14, all divided by 2 times 1. Well, negative 7 is 7 plus or minus root of will be 49 minus 56. It appears that I like 7. A lot of 7s floating around. Anyhow, we're going to get a negative 7 here. So that's 7 plus or minus the square root of negative 7 over 2. I'll keep it in this form. And write my negative 7 is 7 times the square root of negative 7 times negative 1, which gives me square root of 7 times the square root of negative 1. We're used to this. And that's 7 plus or minus 7i divided by 2. You can write that as 7 half plus or minus 7 half I. Okay. Or we could write it, this would be fine, but we could also write this as 7 half times 1 plus or minus I. Couldn't factor out that 7 half. Not necessary to do that, but hopefully, you know, think about what kind of factor out there. Now, I think in the previous solution, there was nothing really would factor out. Here, we could have written this as 1/6 times 9 plus or minus the square root of 21, but we wouldn't do that. But a lot of times we might do this. In this course, not something we worry a whole lot about. Again, just pointing out that if we factor something, we go ahead and do that and write the solution both ways. Okay, so all solutions are complex. Complex numbers. Okay. Okay, I've said some really profound things really, really well, better than they've ever been said in the history of mathematics instruction. And I didn't record it, so I'm going to have to just say them. Okay, so this is probably going to be a little below the point, but I'll say it kind of quickly. We have y equals a function of x, f of x equals 3x squared minus 9x plus 5. And don't worry too much about that f of x. It's just a way of naming this and referring to some points, to general points on the graph. And we'll see more about this later. Okay. We've already solved the equation we get when we set this expression equal to 0. And of course, that's what y equals. So y equals 0 if x is equal to this or this. So these are the solutions we got, and we approximated them. We get about 2.3 and negative 0.8. Okay. I estimated the 100, but that 100 isn't real reliable. I'm telling you that any quadratic function, this is a quadratic expression of ax squared plus bx plus c, gives us a parabolic graph. Parabolic graph is just like the graph of a y equals x squared function, except it might be skinnier or fatter, and it might be upside down, and it could be anywhere. It doesn't necessarily have to have its vertexes to it. It could be over here, down here, up here, down, up here, up, whatever. Okay. Now, the way you generally graph expressions like this is you plug in numbers. If we plug in 1 for x, we get, x squared is 1, x is 1, so we're going to get 3 minus 9 plus 5, that's 1. We plug in x equals 2, well, x squared is 4, so that's going to be 12. Negative 9x is negative 18, 12 minus 18 is negative 6, add 5, we get negative 1. So that's like here. Okay. Which is problematic for my solution, that I've made an error in my solution. There's something wrong here. I'll tell you what it is. Did I do my arithmetic wrong? I've done something else really good. Uh-oh. 3 minus 9 is negative 6. And add 5, we get negative 1. So the point here should have been 1, negative 1. That's the big one. So doing my arithmetic a little more carefully, you see that we have 2 points on the graph. That's still a little bit disconcerting. Because of the 3, that's all right. Okay, if x is 0, x squared is 0, so 3x squared is 0. Negative 9 times 0 is 0. So we get 0 here and 0 here, but then we have a plus 5, so that we get plus 5. Okay, well, 1, 2, 3, 4, 5 is up here. So here's a 0.05. Okay. Now we've got these 2 points. So if it's a parabola, it's pretty obvious that things are going to have to come down here like this, go through this point, turn around, and come up here like this. If it has this shape, if it has these 3 points, it'll pretty much have to look a lot like this. Okay, the points zero, three halves plus 21 over 6. And we approximated that by 2 halves plus a square root of 21 over 6 is about 2.3, right? And that's totally wrong. I've done it right again. When x equals this, y equals 0, right? So the 0 should have been the y coordinate. Okay. And this number should have been the x coordinate. And all this says is if you plug this number into here, you're going to get 0. You can check that yourself. It works. Now I estimated this at some as 2.29, but pretty much 2.3. This point has to lie on the ground. And this point is real close to 2.30, right? Does that make sense? Well, let's look at this point here. Could that point be 2.30? Well, here's 1, 2, 3, so it's between 2 and 3, right? A little bit to the right of 2. Now, if I was estimating that, I might estimate 2.2 just from my picture. But drawing an approximate curve. So this point should be treehouse plus a square root of 21 over 2, 0, which is approximately 2.30. So far, my solution's looking pretty good, isn't it? I don't know if I messed that up. I'm sure I messed something up. But I think I got that one pretty much first try. Okay, look back at the video and see. Maybe not. Okay, well, remember now, where did this come from? This solution came from just doing what we do with the quadratic formula. And all the way down to here, it's correct. I don't know if my estimates are correct. Remember, I estimated 2.29 or negative 0.71. Now, I'm not sure about the 100. That could be 2.28, negative 0.72. I think it's one or the other, but I could even be wrong about that. Notice that I put this solution in braces, set braces, okay? Because it's a set of two numbers. It's not an ordered pair. The point 2.29, negative 0.71 is not a point on the graph. Those are the x coordinates that make this 0. Okay, well, this solution is this. This solution, look at this statement. This value of x makes y equal to 0. So this tells us that this point has to lie on the graph. And x equals this, y has to be 0. That's actually I should have been, I think I should have been 0.79. No, 1.5 minus 0.79 is 0.7. Okay, I did mess up on this solution. 1.5 minus 0.79 is not negative 0.71, it's 0.71. We should not have had a negative on the 0.71. Okay. So that part of the solution, that estimate was wrong. And you can get 0.710. So these are points on the graph. These points are called the x-intercepts. That's convenient if you remember that terminology. But you'll be seeing it again. If you don't remember right now, no big deal. Be toward the end of next week. The earliest when you have to worry about this. Okay. Now, this tells us that 0.710 equals 3 halves minus the square root of 21 over 2, 0. That's approximately 0.710. And that's this point here. Does that look like 0.70? Well, that's exactly what I'd estimate if I saw that point. Okay. Okay, so. You all check your masks. You all been really great about masks. I think you mentioned anything. In case you haven't heard, Delta's resurgent once more. And you really do have to be careful about it. Although we were going to beat it, we follow the rules, and I'm saying that for the choir because y'all been following the rules really well. Okay, so there we have it. So the quadratic formula tells us exactly what plotting 3 points would tell us. Okay. Now, you want to use this information because if you don't use this information and the graph happens to be out here someplace, plugging 1 and 2 in here is going to give you something way the heck up there. Okay. It's not going to give you any good information at all. It's not going to tell you anything useful. You're going to have to plug in numbers like x equals 15 and 20, but you don't want to have to keep plugging in numbers to graph that. If you solve the equation, you set this equal to 0, it gives you a lot of information about where to look to find the important part of that graph. Otherwise, you just get big old steep lines that don't tell you one thing or another. Okay? There's actually something you can do with the slopes of those lines, but you don't want to know it. Okay? You don't want to mess with that. That's kind of getting toward calculus or somewhat simple advanced topic, pre-calculus. Okay, well, you don't want to go there, especially in this. Okay. There's more. Okay. Those points, and that's easily found by using quadratic formula. Just this equals 0 and so forth as we've done. But make sure I'm on the same page here. Okay. Now, here's another important use of the quadratic formula. I have 0. These aren't zeros of the quadratic function. This thing has solutions. this bar to the right and left of x equals negative b over 2a. We could write this as negative b over 2a plus or minus this, the square root over the 2a, right? Well, negative b plus this is on one side of negative b minus this is on the other side of negative b, equal distance because it's the same expression. And we can put it over 2a, you draw this conclusion. Now, I'm not going to emphasize that. If you understand what I just said, it's really good. But otherwise, for the moment, you can take this as a rule. You look at the quadratic formula. And you just isolate this much. And that gives you and its solution is not solution. Okay, gives you this. Well, y equals 3x squared minus 9x plus 5. Equals negative b over 2a, which is going to be the negative of negative 9 over 2 times 3. And you do the arithmetic, you get 9 over 6, which of course we saw right here. That's your negative b over 2a, because that's exactly where it came from, negative b over 2a. So it's right there inside the quadratic formula. Make this plausible then. Let's look back at it. First of all, 9/6 is 3/2, which, since we do decimals over here, is 1.5. And I'm not sure most of this that I actually get. I put off here. You got most of this. Let's take the camera back 1 minute. And that should just say everything. And we have this on that. That's all this. Start that just a bit. I want to keep the board as big as possible. It's easy to read. Okay. Okay, sorry. Okay, so again, what we've said now is your solutions are at equal distances to the right and left of x equals 3/2, which is your negative b over 2a. That's about 1.5. Now, where is the line? X equals 1.5 is a vertical line. Okay. We can say all points where x equals 1/2 lie on the vertical line. Through 1.50. Where's that vertical line? Where's the point 1.50? It's right here. This point is to the right, this point is to the left. They're at equal distances. It looks that way, doesn't it? In the vertical line through this, off the right, there. I might have a chance of doing this vertical line right where it ought to be. Okay, so here's a vertical line. X equals 3 halves equals 4.15. Does it make sense to say that this graph is symmetric around this line? If this is a mirror, if this line is a mirror, then the mirror image of this part is just this part, isn't it? Don't we have mirror images across this? What do you mean by symmetric? Okay. Vertical line here. Zeros are at the distance. Square root of b squared minus 4ac over 2a, which is approximately 0.8. Divide them up. Okay. If you understand this, at least by the other next week or the week after, then you have a very good head start on recalculus. If you don't, well, you're still going to work through some stuff. And at least you will have seen it. So when you have to do it in pre-calculus, it's going to be a lot easier. Okay. So let's pause this for a second.